Well, hello everyone, this is FixReef, and today we have a different device in for repair. Yes, this is the Apex Sky unit. I have repaired so many of them, and then you guys are asking me, keep asking me if I'm working on these lights, and I haven't had a chance to put together a video on repair of this. So recently I have received several of this info repair from different customers, and I decided to finally go ahead and record a video. I tell you, after repairing so many of this at this point, this is a very interesting endeavor by Neptune, completely out of the realm, and the result of that is what you can see here. I'm not going to comment a whole lot on the quality of this unit. Some of you already know. Many of you are probably not even familiar much with these lights. They're no longer in production. They were released a few years ago, kind of a short run for a light like this, especially from a manufacturer like Neptune. So eventually they stopped making them, and at this point they don't even support them as much as far as repairs go or maintenance goes. So let's go ahead and start disassembling this just to see what's inside. This is a fairly large unit, so I'm going to have to kind of show that in pieces on the camera. It does not fit into the view of the camera entirely. One of the guesses that I have, and I haven't really been following a whole lot on this, but one of the guesses that I have is that whenever Neptune and Radeon became one company, they kind of gave up on Sky because there is already Radeons, and maybe that's why they kind of stopped making them. But also could be because let's be honest, they have hired a recent graduate out of an electrical engineering school to design this, and they have hired probably an intern in case design to make this unit. It's mind-boggling, really. Nonetheless, I am fortunate enough to be able to repair any kind of problems with this unit, including the main controller. So I have done repairs in the past that included severe water damage, shorts on multiple channels, and so on. Interestingly enough, and I'm not sure what to make of this, but I haven't had to replace a single LED on these units. That's what's bugging me about this. With Radeons, I mean, half of my repairs, larger half of my repairs is replacing LEDs, and with this one, not a single LED replacement yet. However, everything else about it is just bad design. Okay, starting from the point of taking it apart. Just taking this unit apart is a major hassle. There are very few lights that are like this. Which makes me wonder if whoever they hired to design this hasn't done a very good job. It's a bulky light. It's supposed to be, I guess, wider spread than Radeons, but it kind of reminds me, I cannot help but think of the Chinese black box. And you will see the reason why once I open it up, if I open it up. So on the inside there is a fairly large array of LEDs across the entire unit. So the array is held together by a collection of screws and a big sort of a screen made out of some type of plastic. The center screw is actually different in length, much longer than the rest of them, and there is a reason for that. Once we remove the screen, the LED panel is exposed. The LED panel is quite thin. That does remind me of a Chinese black box. Better LEDs, perhaps, but other than that, a Chinese black box type arrangement. Alright, so that aside, There is not a whole lot left here. There is the entire LED control board is over on the side here. Not sure how much of this you can see. I guess it's right here. Long board that controls various channels. And Sky doesn't actually have a whole lot of channel control, but they just decided to run a string of LEDs off of each of these LED control pieces or circuits, and there are so many of them. Alright, well, it's taken apart. Now we need to figure out what actually is wrong with this. My guess is that it's going to have a bad LED channel here or there. Let's find out. Oddly enough, I do not hear any kind of fan movement whatsoever, so I think that the problem is deeper than just LED channels. And apparently when I plug it into the main unit, the head unit, it completely shuts off the head unit. So we have a problem. And the problem is not necessarily with the LEDs. So we need to be able to get out this little board over here. But we can't really move it out to get it out because there is a little shim here that's holding it in place from being disconnected. A smart move, because if you don't put that rubber button here, vibration can disconnect and dislodge this entire little board that's connected to the LED cluster. So to get it out, we'll have to actually remove this piece entirely from the top cover to expose the rest of these components. So if you're doing a disassembly of this unit, just like with the EB832, you have to pay very close attention to any kind of cables. So there's a flex cable over on the corner here. It's actually generously long, so that helps. But if you rip it out and not careful about it, you're going to have a problem. Okay, so the only thing that's on the top cover would be the Wi-Fi module. The Wi-Fi module with its own, essentially its own power board, and that left side of that power board right now is the one that's responsible for powering the Wi-Fi module. There's nothing else here. Okay, so what's left is fans, the heatsink, and the boards that control the LEDs. That's all what's in it. That's all what it is. So on the side over here, there are a couple of connectors. What we can do is carefully remove the connector board. That exposes cabling. Disconnect the cables, both fans, and we can set this heatsink and the main board of the LED clusters aside. I would like to focus right now on this little board. So let's zoom in. You can take a better look. So there is nothing really over on this side of the board, so nothing to worry about. But on this side of the board, what do we have? So starting from left to right, connectors that provide power into the unit, provide Aquabus connection into the unit, and fans. Then we have a communication module that's responsible for Aquabus communication, so CAN bus. The main controller, the power that provides, and the power circuit over here that provides power to the main controller and the communication circuit. This is of course our voltage regulator here, very typical. You can see those on EB832s and probably every other unit that Neptune ever designed. And then there is this right here, right there. You can already see probably that this specific component is completely busted. This is the same unit that they install in EB832. This is a buck converter that takes 36 volts in this particular case and converts it down to about 12 and then the voltage regulator takes 12, it converts it down to 3.3. For the main controller, the 12 volts go for the fans and go into the Aquabus circuit. And that is the reason, that unit is the reason why Aquabus shuts off. Because obviously there is some kind of power issue going on. It's entirely possible that the Aquabus circuit is also busted, but we'll have to find out. In the meantime, let's just start fixing what's in front of us. This is not really a microscope kind of repair, but for the purposes of demonstration, I'm going to get under the microscope as we remove this little component here and replace it. And so this is our buck converter that's completely busted. There's a hole in the middle of it. Clearly there was a damage. It looks like there might be damage to some resistors around it. We'll have to find out. But for now, let's just remove the unit. Nice and easy. It's gone. So before I clean up, I'd like to know if the resistor next to it is also gone. So let's test that. That should be a very, very low resistance unit. And it looks like it's gone. Yeah, that guy is gone as well. So that one we can easily remove with just the iron. Well, let's hope that that's it. Although, now that I'm thinking about it, I want to know if the main controller or the communication controller were damaged as well, because there is a reason things shut off. Doesn't look like the 3-volt circuit is damaged. Yeah, looks good so far. There is no way for me to tell right now if the CAN bus is functioning. I won't know until everything's powered, but at least for now, I know that there isn't a short on a 3-volt circuit. Alright, so over here it looks like one pin, one pin of the buck converter is still in there, so we'll need to remove that, clean everything up, and reattach. Usually when it blows up like this, those pins get kind of welded onto the pads, which is not really a great thing because it makes it much harder to remove, and this pad is about to, I think, come off, unfortunately. Not a big deal, but I would rather not break more than I have to. The pad is mostly gone, but so is the pin. Again, not that big of a deal. Can be restored, but it is what it is. Sometimes I enjoy working on Neptune hardware because it's fairly simple. There isn't a whole lot of sophistication to theirs, and so the repairs are usually not that difficult. On the flip side, however, Neptune's notorious for not allowing anyone to have access to their firmware. And so I don't really care about their firmware. I'm not going to replicate or use the firmware to replicate their devices. That's their problem. But for repairs, it would really be useful to be able to just replace a controller and reflash it with fresh firmware. So I find my ways, but it doesn't have to be hard. Okay, so now this needs a whole lot more fresh solder. Even the piece of the pad here that's kind of gone. And of course, the resistor. Okay, well, let's put the controller on first, then we'll work on the resistor. As always, I put a little bit better quality units. Although the reason this blew up, I have no idea why. Something was plugged into it that was wrong. But at least I'm giving it a slightly better chance of surviving next time something like this happens by just using a higher quality buck converter. And just like that, we don't have to even worry about the partially broken pad. We have enough of it to put the pin on. but I do need more flux here. Looks beautiful. Now we just need the resistor. All right. I should have secured the board. It's dancing all over the place. Good enough. Good enough. Okay, before I clean up, let's test this. Just like with nearly everything, there is a way to test without necessarily connecting this to the main unit. At least partially, at least we should be able to test power. So we're going to use the pins to power the unit up. Let's try, how about this? And how about here? Okay, so let's see if this provides any power to the circuit or it's going to completely blow up on us. Looks like there is still a short. Just applying very little causes a short. Oh, then we have something else. I am not sensing any kind of short on this. I guess we have to use the thermal camera. Okay, let's see. I'm not sure how much you're going to be able to see. Hopefully everything. Let's power it up. And right away, something is heating up. Looks like the controller we just installed. All right, so one of the other things going on here is there is a small diode over here. And it looks, well, diode's not supposed to at all cause this. So let's see if diode is our problem. Let's see if the short goes away. And it does. How about that? Oh yeah, well, let's get under the microscope and put the diode in. A new one, anyway. I'll tell you a story about those diodes a little bit. So diodes in buck converter circuits play kind of a crucial role. If you look at a typical buck converter schematics, there is always a diode in there. And they're there so that the coil, the inductor here, can do its magic so that the current flows one way and not the other way. So initially in like EB832s and stuff, there was a large diode. It's a main power diode that they would install, and that thing would almost never break. But in this smaller board, they decided that they need room, and they've replaced it with a much smaller diode. Now, the smaller diode is supposed to be rated pretty high because you can kind of see over here. I put the diode over on it's upside down here. You can kind of see that one of the pads of the diode is actually quite large. The other one is much smaller, so it's supposed to conduct quite a bit of current. In reality is, of course, that it's pushing the limits. And as it's pushing the limits, it may eventually break. So you see diodes like this failing, for example, in Kessel's, the older 360W lights. Same kind of concept. And they would fail quite often. I do see these diodes failing in Sky specifically. And that is the reason why I actually have plenty of them in stock. Because I know that they do fail. So, well, let's put the replacement in. And just like that, I'm going to even keep all the solder around it, those solder bulbs, because I want heat dissipation as much as possible out of it, and contact surface as much as possible, because again, this diode is too small, I think, for this application, but what do I know? Okay, now that we are zoomed out, let's find out if the voltages match my expectations. Let's start with an easy one. Do we have voltages, good voltages coming out of the 36-volt circuit. Okay, we have 13 and we have 3.3. Wrong polarity, but doesn't matter. What matters is that we have 12 and we have 3.3 coming out. Now we see the same 3.3 at the controller and the same 3.3 at the CAN bus. Okay, so that's good news. What I still don't know yet is if this can actually talk to the main unit. Hey, look, I think I hear the fans running. That's good news. All right, let's plug it into the main controller. Okay, look at this. Looks like we have, yeah, we have Sky connected. Yeah, needs an update, but it's connected. That's exciting. So last but not least, I'm gonna test it with the LED cluster connected. There you go. Looks like everything's working. And I bet you can control it. Shows volt error, but that's because I didn't have everything connected. It will change. So I can turn off the moonlight. And I can turn on this to full or to medium. And the volt error is supposed to go away in just a couple of minutes. Well, I think we've repaired this light. It needs to be assembled, and I will do this behind the camera and not bother you with the reassembly details here. However, I wanted to show you something really interesting. It took me a little while to figure out why most of the screws are about this size, but the center screw is twice as long. And to make things more interesting, where it screws into on the back is a 3D printed little tiny shim over here. It took me a while to figure out what this is for, until I myself ran into an issue reassembling and testing one of the slides. So let me show you. So this is the top of this unit, and you can see that there are openings for the fans, and the plastic is kind of flimsy. It's kind of thin. It bends and it turns and whatever. So the little shim that you just saw, the 3D printed shim, gets installed right here in the middle and gets placed right here in the middle, in between the two fans. And the reason it exists is if you don't have this, what happens is there could be occasions where the cover kind of caves in. And as it caves in down, the fans that are underneath connected to the heatsink, which are not necessarily connected to the top, start rubbing against the covers of those screens. And that's not a very pleasant sound. So what they ended up doing is they ended up installing a longer screw and putting a little bit of a shim that it screws into, so that that screw is holding the top, the center of the cover in place so that it does not cave onto the fans. Well guys, this was one story of a Neptune skylight. Skylight that at this point is no longer supported, is no longer manufactured. And I do a lot of repairs on these lights lately, primarily because when people call Neptune, they tell them, well, look, we don't make these lights, we don't have parts for these lights anymore. So I end up with doing most of the repairs for Neptune for this, one way or the other. You draw your own conclusions. This was a simple-ish repair, and I didn't get a chance to show you all of the intricacies of this light. There will be other chances, I'm sure. But for now, that completes the repair. Thanks for watching. We'll see you next time.